All right, welcome to the AIA Silicon Valley class concerning best practices for surveying, drafting, and modeling as-built plans. I will be your sole presenter. My name is Colin Maloney. I work for a company that does nothing but produce as-built plans for architects like yourselves. I've been fortunate enough to see the production methods change over time. And in doing so, I hope in this presentation, I'll be able to helpfully impart not only some of the best practices for as-built production, but some of its history and evolution as well. So in the 4 parts of this presentation, first, we're going to touch on just what as-built plans are. We'll go through some common definitions. We'll talk about when as-builts are needed and also when they may not be needed. We'll talk about gathering various degrees of information and when projects require a more detailed scope. And then once we've touched on that definition and understanding of what as-builts are, we'll get into how to get them, starting with the more traditional surveying methods. We'll talk about sketching on site, getting those plan view measurements, and also the z-axis or height measurements. After that, we'll go into the new era of as-built plan surveying, laser scanning. And in doing so, we'll talk about terrestrial scanners, we'll talk about mobile scanners, the point clouds that are created from these scanners, and then also using those point clouds. And finally, we are going to get into actually creating an as-built set. We'll talk about drafting from the traditional methods again, go back to that, and then we'll touch on drafting and modeling from point clouds as well. All right, so jumping right in, what are as-built plans? Let's start with some common definitions. When looking into the actual definition of as-built plans, what one will mostly find is a definition that concerns as-built plans being created after or during new construction or after or during a renovation. So this definition reads, as-built plans are prepared by the contractor. They show in red ink on-site changes to the original construction documents. They are more like interpolations done for construction purposes. Therefore, the changes that occur that the contractor makes onto the original design are called as-built drawings. So contractor developed as-builts are not to be confused with record drawings created, of course, by the architect or engineer. Record or archive drawings often include the information gathered on as-builts and are the final set of formally developed prints signed and stamped by the project engineer or architect. So this definition reads, record drawings are prepared by the architect and reflect on-site changes the contractor noted in the as-built drawings. They are often compiled as a set of on-site changes made for the owner per the owner-architect contract. And I did forget to mention that we're going to be taking a couple polls, and the first one is right now. So what I'm going to do is initiate the first poll. And this is this question. How many times has a contractor you've worked with actually created as-builts for you as described? And the 3 options are never, sometimes, or always. So please go ahead and answer this poll question. If you have that capability, you should be able to bring it up. We're getting some answers, so it looks like you've been able to do this. I like that. Not seeing anything in the chat as far as difficulty in doing so. And I'll end the poll in about 10 more seconds. Looks like almost everybody's had a chance to answer thus far, which is great. So now I will go ahead and end the poll and share the results. Let me know if you can see that. It looks like about 44% said that this has never happened. And 56% said sometimes. So that's interesting to see. And we're going to kind of tie this together now that we've seen that answer. Okay. So, all right. Let's move on to what an as-built plan is again, but this time just keeping it simple, and also a definition that I'm more familiar with in my world, in my profession. So I think we all can agree perhaps that in architecture and construction, as-built refers to a drawing that shows the existing dimensions and conditions of a building, space, or area. Plain and simple. So let's move on with this presentation just using that definition. And before we do, I want to say that throughout this presentation, we'll be discussing producing as-built plans in their final format as either a 2D CAD file or a 3D Revit model. Both are softwares created by Autodesk. As you likely all know, there's many other drafting and modeling softwares out there. So even though I'm mentioning this Autodesk software throughout the presentation, you can pretty much apply any points I make about 2D drafting to other softwares or 3D modeling to the other softwares you use, such as ArchiCAD or DataCAD, Chief Architect, Vectorworks. There's several others. So just kind of, when I mention things, you can put it into your own context for your own workflow. All right, so now that we've defined somewhat what as-built plans are, we'll talk about when are as-builts actually needed. Pretty much whenever we're working with an existing building, we'll need as-builts before starting our new design. If the owner or client happens to already have as-built drawings, then we may need to just enter them into CAD or reformat them if they're already in CAD and confirm that the drawings are up to date. If errors or inconsistencies are found, at some point you may decide that a fresh set of as-builts are needed. Let's also talk about when as-builts are not needed. It's rare that clients already have current as-builts of their existing building, as we saw in the poll, but it does happen. So in that case, of course, you would not need more before starting your project. There's also simple cosmetic projects that don't require having accurate as-built plans. And of course, if a building is being built from scratch, under that last simple definition, you are not going to need as-built because it's a brand new construction and all you'll need are your construction documents. Okay, so when's the best time to obtain as-built plans? In most cases, the as-built files is the very first step. So in the renovation, if not, the very first step. So that's probably the time to get them. Getting ahead of this step allows an architect to focus on their design and plan creation. There's also cases where you'll be submitting to the historic review and they'll require as-builts before you start. And even sometimes when you're working on a teardown project, some building departments will require you submit as-builts of the buildings being demolished. So as I mentioned on the previous slide there, different municipalities work differently and have different requirements. If they require as-builts for any reason, or the type or scope needed may vary from city to city. If you plan to improve upon detailed architectural elements, such as ornamentation, you'll need to consider that and documenting it and where it fits in your timeline. And overall, the size and the scope of your project will determine when as-builts are needed. And as we'll discuss in the next section, to what degree and scope the as-builts are required. So you've discovered you need as-builts. How far or in how much detail do you need that information to go? So above are a few examples of plan types and when they're needed in your as-built plan set. You almost always will need floor plans. If your work is impacting the exterior, then you may need exterior elevations. If you're working on an existing structure where there's height constraints or funky ceilings, soffits or anything like that, you may want to look at getting a reflected ceiling plan and just knowing that vertical relationship sections can be beneficial. But ultimately, it's up to you as the architect to decide the scope for your as-built plans or consult with your engineer on what's needed. So let's get into some of the different ways to gather different degrees of on-site information. Before we get into specifics, we'll talk about, simpler stuff, and then we'll launch into getting a full-blown as-built set. So one way to get on-site information is photos only. To obtain the answers you need on site before renovation, just take some photos. They can assist in the design process and answer questions you might have. Sometimes a quick single line or even bubble diagram is all you need to achieve your goals. This can be achieved quite quickly on site and does not need to be to scale. Sketching can be very helpful in supporting your design. In the case that interior elevations are perspectives, this can be done roughly and not even require measurement most of the time. If the drawings need to be to scale, and if you're going to use them to create your construction documents, then you'll need to go to a higher level of accuracy and go ahead and go out and measure the existing conditions. Most remodel projects require a more detailed scope for as-builts. That's the simple truth there. It'll give you the head start that you need in creating your design and submittal and construction documents. So, to sum up the first portion of this presentation, as-built plans, simply defined, are a set of plans of any structure as it exists at that moment. They're often used for renovation of some type. Getting as-built drawings in the format in which you work is important, such as a particular software, or at least a software that you can easily convert to yours. The scope of the as-built plans and the detail of each scope item will vary with the needs of your project. Now that we've defined what they are, let's talk about how to gather that information on site. And we're going to start with some traditional surveying methods. First is something near and dear to my heart, sketching. So here's how you might sketch. First of all, remember that your sketch does not need to be to scale. All you need to do is make sure that there's room to write in all the measurements you need and that it's visually easy to follow when you're back in the office. And I've had plenty of sketches that aren't. You're going to want to use different colors to mark different measurements and drawing types so that your eye can catch each segment and you're not spending as much time hunting for the measurements that you need. Get as much sketching as you can done before measuring. That way you can just focus on your measurement and execute when the time comes. The better your sketching is, the easier your measurement will be. If you've correctly sketched a structure, then the measurement will be done much more quickly than if not. So, and also make sure you leave plenty of room to write in those measurements, because that's the really important part. Plan ahead to get those height measurements or the Z-axis measurements. Most of the time, this information can still be displayed in plan view, but occasionally you want to sketch in a section or an elevation view to visually display those heights. And also you might want to sketch out any details or ornamentation to the degree of precision you desire to be able to add those measurements later to those items. All right. Now that you've done your sketching, it's time to measure, and we'll start by talking about some plan view measurements. An important step that many people skip when measuring a structure is going around the exterior faces. Often a wall thickness is measured, and then all the rest of the measurements are all on the inside, and you just assume that exterior wall thickness. I consider this step to be crucial. So you want to start with all the exterior faces, measure 360 degrees around, and then check your work at the end. You want to add up all of the X values in your measurement and then add up all the Y values. And if you can see on this sketch in the lower right portion, I've done that math. And if, this is all inches, by the way, that's the way I measure because it's just one single measurement to write down. I don't do feet, inches when I'm writing. But if you get that within an inch or two and you've measured a whole structure, then you know that you're on the right path. This, of course, can get complicated if you have a building that's angled, not rectilinear 90-degree angles, if you have odd angles or curves. But then you can just get creative, go back to what you learned in geometry and do it. There are ways to get that done. All right, in this sketch, you may notice there's some overall measurements in red as well as incremental measurements in between. This is a good system of checks and balances that'll improve your accuracy and also save you in the event that you have an incorrect measurement or notation. You know, you have the small ones, but they're backed up by the larger ones in most cases. And don't forget to get good photo coverage as well. That will help you verify that what you're drafting is correct. Occasionally I've seen errors that don't appear as errors on paper. Everything looks great, everything adds up, but it's really obvious when you look at an image. So yeah, even if the math all adds up, you could have done all those measurements wrong. And a photo will help you check that quality. So another tip is to bring vellum. In this sheet, you can see that the underlay is the previous sketch with all the controlling measurements for the walls, windows, and doors. And there's a sheet of vellum over it. And this allows you to take the information from that first sketch and use it and add more symbols and measurements on top. All right, so now we will go on to the z-axis or height information. You can use a tape measure to measure all the risers and the stairs and add it all up. You can drop it down a balcony. You can run it up a wall. A laser distance meter or a disto can perform all sorts of trigonomic functions instantly and get you heights in all sorts of tricky ways. And these first two tools can be used for all the plan view stuff too. So you might be already using them on your measurement, but this third one is used exclusively to find height information. It's called a zip level. And it's an excellent tool invented, distributed, and repaired if needed by a company out of San Diego. I'm not aware of any other version of this tool. Later, if anybody knows of one, I'd love to hear about it. And I know that it uses displacement to read heights anywhere within a 50-foot radius. And it's got a cable so you can move around easily. All right, so you want to, however you collect those heights, you want to make sure you've got them in the places that you need them. Most of the areas will be obvious, like the tops of any steps or staircases. Plan ahead on what you'll need to see in those exterior elevations if your plans require them. Make sure that you have some height and pitch information for your roof, or you have every height on the roof. If it's safe to climb around up there, of course. Make sure not to forget the heights of openings such as doors and windows. And if you're going to do an interior elevation, you might want to measure to the top of the countertop, the bottom of the upper cabinets, or the wall sconce that's hanging there. Or even if you're getting high detailed, the height of the electrical fixture off of the finished floor. So, in summary, having the perfect sketch isn't important. What you need is a sketch that displays and contains all the measurements you'll need when you start drafting. You'll need to encapsulate the structure by measuring around it. This will give you the scale when you begin drafting and ensure that your interior measurements don't start bulging out of the structure, which sometimes they tend to do if you wrote something down wrong or measured it incorrectly. That will keep you bounded in. And after taking the measurements of the major items like walls, windows, and doors, then you can go on to the next level of detail as needed, whether it be just the plumbing fixtures and cabinetry or electrical and RCP. You can go from there as far as you want to. And now for our next poll. Let's see. Here, I'm sorry, I'm going to go to the next poll. I see, poll 2. There we go. How comfortable are you with sketching and measuring your as-builts? The first answer is very uncomfortable. It makes me sweat just to think about it. I've done it, but I don't like it. I am comfortable doing this, and I always sketch and measure my as-builts. I love it. I'm getting some varied results here. Interesting polling. Please, everybody participating, don't be shy. Let me know what you think about this as-built process. Be honest. I'll give you a couple minutes if you need to think about it. We've got 75% of you have voted. And I'll give it just a couple more seconds while I take a drink of water. All right, so it looks like we've got some comfortable measurers out there, which is great. So this is good to see, and hopefully maybe I was able to impart some tips on those traditional methods there. So yeah, let's move on, and thank you so much for participating in that second poll there. All right. Now we're going to get into the new era of obtaining as-built information, laser scanning. To change to a completely new technology and ditch some of the traditional methods isn't easy in any industry. I was admittedly skeptical myself, but using LiDAR allows for fast data acquisition if you're a skilled surveyor using it. It's more accurate than any measurements that you can take by hand, and I can vouch for that now that I've been doing it for years. The technology can be purchased, rented, or contracted. It's a thorough solution. It allows you to gather more data than less data to complete your project. And it provides a digital twin to pull additional data down the line if your project needs to be revisited or additions need to be made to the scope of work. So now here's some examples of each type. We have a terrestrial standing scanner or a mobile walking scanner. Either way you choose to go, you'll be using LiDAR to create a point cloud. So LiDAR is a method of measuring distances by illuminating the target with a laser light and measuring the reflection with a sensor. Each one of these illuminations can be considered a measurement. Each single measurement is logged, and throughout the course of the scan, millions of measurements are taken in all directions. So first, let's talk about a terrestrial scanner I'm familiar with. This is the Leica BLK360. Overall, you'll find that terrestrial scanners like this one will give you a much more rich, dense point cloud than a mobile scanner would. Some terrestrial scanners offer extremely high levels of precision to their clouds. So in the next scan, we'll see a short video of a scan of a single family residence taken with this scanner, okay? All right, here we go with that. Oh, it disappeared. Let's bring it back. All right, so as it zooms out, it's going to be rendering a little bit, but when it comes still again, you'll be able to see the full image once again. And just to comment on this, you can see that it's collecting information all around the subject property, front yard, backyard. There's actual visible color, and this has thermal detection capabilities as well. If you're interested in that kind of measurement, notating like, leaking air or heat coming out of a structure. So really, really precise stuff with some of these terrestrial scanners here. All right. And now let's touch on mobile scanning, and we'll look at a scanner that I'm actually most familiar with. This is the GeoSlam Zeb Revo. All right. The trade-off for a less dense point cloud or a hyper level of precision or no thermal readings is that you have a mobile scanner that you can greatly reduce your time on site scanning. You can increase your mobility since you're moving while you're scanning, and the scanner doesn't need to be mounted to anything. And you can even mount other equipment onto the scanner, such as a GoPro to video your path, or you can take the scanner itself and mount it onto a drone potentially. So now we're going to watch the video of some output from that scanner. You may notice that the coloration of the materials isn't noted with this one, but it does have a height ramp visibility. So different heights are shown as different colors on the spectrum. In this one, you can see that there's blue at the highest points Then it fades into a green and yellow as it goes down. That's just to help you visualize it even further. And that's a single family residence that we scanned right there. One family lives in that monster house. So using a mobile scanner is preferable if your time on site is limited in any way. Mobile scanning can give you the ability to not only scan the project quickly, but have time to process the scan while you're still there on site. And we'll talk about why that's important in a minute. Once the scan is complete, you'll need to process it using the software that's essentially an algorithm that interprets all those little millions of measurements that you took and makes them into a point cloud. So let's talk about this infamous point cloud now. Reviewing all your data well before attempting to create a set of as-builts from it is a must. If there's any kind of errors within your cloud, when they do happen, using that bad data can stop you in your tracks when you're drafting or modeling, or worse yet, you could finish and then just have a bad data set. So once your scan is processed, you'll need to review the output. You need to make sure that you covered all the areas. It's common that you just didn't enter a room or something like that. And if you didn't do it, likely it's not going to be in your point cloud. You want to look for any flaws or errors in the point cloud if possible. And then you also want to check for drifting in your point cloud. We'll talk about that even more on the next slide. Make sure that you look for the drifting, which can occur when the software just has trouble putting all those points together. This is a good example of that here. If it occurs, you can try some reprocessing options or simply scan the structure again. Drifting is common with mobile scanners, and it occurs for several different reasons. Determining which reason is helpful before attempting to reprocess or rescan your project. When scanning attics or foundations, large sites, multi-level structures, you may run into issues as well. Areas that are harder to access, tight squeezes, or areas that have less unique features like repetitive hallways and reflective surfaces can cause issues too. Remember that the algorithm is trying to put this together, and we can, if processing requires all areas have data connecting one area to the other so they can be properly glued together. Mirrors, moving objects, repetitive, non-repetitive, or repetitive, non-unique areas can trick the process and therefore give you bad output. Most scanners have a pretty far range. They shoot out of windows, and when you're outside, they shoot all over the area. So you may need to clip or crop the cloud to reduce the size and delete the unneeded data. If you have to take multiple scans for whatever reason, merging is possible, and knowing how to do it can help you greatly. So much like traditional method of measuring, sketching and measuring, scanning takes lots of practice to do properly and effectively. Let's talk about using the point cloud. So now that you've processed your point cloud and reviewed the outcome of your data, you'll need to do one of the following things. Do it all again if it came out poorly, or go back to your drafting and modeling station and get started with the next phase, which is your actual as-built plan creation. In order to produce items such as a floor plan, you'll need to be able to slice the point cloud into the desired section and work from that. Most software allows you to do this pretty easily. In addition to cutting sections, you'll need to be able to move and rotate the clouds to give you the correct working angle that you desire. And so, in summary, scanning your project can reduce errors and time spent on site. The type of scanner you use will be dictated by your needs and the level of detail required. And your scanner will create a point cloud made up of millions of points. Knowing how to manipulate it is crucial. This way, it will have the utility you need when it's brought into your preferred software. As an added note, I just want to mention that my perspective has been almost overnight as-built production methods have shifted from those traditional methods that have been used for decades to these newer ones utilizing the latest in laser technology. As with every new introduction of production methods, there's a learning curve. But once it's mastered, the entire process gets much smoother. And it's when it's incorporated with BIM technologies, the entire construction process can get a boost in speed, efficiency, and a lesser environmental impact too. So now that we've gathered the on-site information from whichever method we used, it's time to create the actual plan set. It's important to keep these organized and concise, but at the same time leave room for notes and building code information so they can be used for your design layouts, your demo plans, construction documents. So I know we've recently been talking about scanning. Now we're going to shift gears back to the traditional method and how to translate those sketches into great as-built plans. Prop your sketch next to your computer and fire away. That's what I do. I have an easel next to the screen, CAD on the middle, and then photos over here. It's a pretty straightforward process. You're using a vector-based software to draft to full scale, entering the measurements from your on-site sketch. If you're modeling in Revit from a sketch, it's more difficult, but not impossible. You're building rather than drawing. So you often find that you need to let the model dictate certain measurements rather than your own. So now we'll talk about those plan view aspects of your as-built set. For a floor plan, you'll primarily be using the line tool in combination with whatever blocks you've created. The perimeter line usually comes first, as it does in the field when you're measuring. You want to draft in all the walls first, and then the windows and the doors. And again, that's kind of your controlling stuff. And an important thing to recognize, if there's multiple levels to your structure, you not only need to draft using your measurements, but also just be cognizant of those stairwell walls and the exterior faces, and making sure that they line up exactly as they do in real life. Once those controlling items are done, you can draft in with perhaps a little less degree of precision, those cabinetry, plumbing fixtures, appliances. And if you're adding electrical and reflected ceiling plans, it's pretty much the same. Just follow what you've sketched and measured, add the items one by one. So now we'll talk about some other, this is still a plan view drawing, but getting into some of the height stuff. You'll need to at least have sketched the behavior of a roof correctly to draft the roof plan, or at least using a nice clear satellite photo. This means all the hips and the valleys and ridges, the directions of any of the slopes, and this and the measured length of the overhang should get you to a place where you can draft your roof in plan view. On that same roof sketch, as we discussed earlier, you're going to make sure that you have all the height information. This can be achieved by using the zip level, that tool that I mentioned before, actually getting on the roof and taking all the needed height readings. There's other methods, of course, using an angle finder, a level, and the functions of a disto. Drafting elevations will come entirely from your floor plan and your roof plan sketches. The only exception is sketches which show certain aspects of the ornamentation on the exterior. It entails placing all the windows and doors correctly with their correct heights off of the finished floor. And of course, it's important to ensure they correspond directly with those floor plans in all those cases. Any decorative items that you've sketched and measured can be drafted as well. Drafting a roof in elevation view, I can say, is one of the most difficult challenges, as it needs to correspond directly with all the other elevation views. So that's the toughest part. Once the cut location and the direction are determined of a section, you'll use the floor and ceiling information you've sketched and measured on site to complete a section view. To draft the roof properly in section view, it's highly advised that you have your elevation drawings drafted first. That way you can use them to draft your section. Okay, so now we can shift back our thinking to the scanner method and doing this work using the point cloud that we've created. If you use laser technology to measure, you'll be drafting from a point cloud. This can be imported directly into your CAD or Revit software. Autodesk requires that you use another software called Recap to prepare the point cloud for the import and ensure it works with their software. Of course they do. Drafting from a point cloud in CAD is pretty straightforward, but it takes getting used to. There's lots of options in CAD to adjust the cloud in several ways. You'll need to adjust the view cube or rotate the UCS orientation properly to work with the cloud in different positions. Modeling from a point cloud in Revit has a few less options, but since the entire program is focused on modeling from a particular view range, it allows you to manipulate your model and the cloud simultaneously. Remember, the point cloud's a three-dimensional object, so when you bring it into 3D software, the two can work with one another fairly easily. So first, we can talk about drafting from plan view items from a cloud. When drafting in CAD from a point cloud, you want to ensure that the cloud is positioned orthogonally so that you can use the ortho function in CAD to draw the lines. As you can see with this house, you need to switch to polar a couple times as well. Positioning your cloud on the Z-axis is also desirable in CAD for several reasons. You should be able to drive all the walls, doors, door swings right from the point cloud. Window information can be found as well if you're skilled at reviewing the clouds. Most scanners won't pick up the smaller items, especially if they're flush with the walls or the ceilings. So trying to locate them in the cloud can be very, very time consuming. I'm talking hours. So oftentimes it's better just to revert to the traditional method while you're in the field and sketch and measure these items. So now let's get into drafting other views such as elevations from the point cloud. This is where you have a huge advantage in having a complete point cloud for drafting. Provided you're able to access the roof in scanning, you'll have a complete picture of not only the roof behavior, but also every height you need to properly draft your roof. Your exterior elevations, your sections, all that stuff. As with electrical and RCP, sometimes it's beneficial to revert back to traditional methods for ornamental items. If you have that window with kind of like a funky mullion thing going on, you might want to just sketch that, and that way you can draft it into your software quickly rather than try to hunt for it all in the cloud. Okay, and now we will touch on the Revit as-built model or the 3D as-built model. And to do so, you got to talk about level of development. The level of development system was created for the AEC community to put standards on BIM drawings. It rates the precision, detail, and overall refinement you can take your model to, with level 100 being the lowest and level 500 being the highest. 100 just means you mass basic geometric shapes roughly, and 500 is so detailed that you're virtually just building a virtual version of the structure in Revit or whatever 3D modeling software. When modeling as-built plans, LOD 2 to 300 is the applicable range since you're assessing a structure that's been built and you're assessing it from the outside. All interstitial spaces are inaccessible and their construction cannot and should not be assumed. When electrical and RCP elements are needed in your as-built model, they'll likely be drafted into the plan set in a way similar to CAD rather than 3D Revit. The items are placed correctly in their 3D locations, but may not have 3D functionality themselves. Revit has many tools to build site plans and topography. If you only need to model the structure, you may want to limit your site work to the areas that surround or touch the structure only, if at all. Wait, I just want to touch on one other thing. In the case of exterior elevations like this one, you want to make sure that the finish grade is accurate along the face of the house. This can be achieved without going into all those topography tools. You can just use some simple drawing tools to do this. The as-built, well, I just want to say there's some advantages to having a BIM as-built, which you may not know. Sometimes a three-dimensional model is only considered for presentation stuff or design stuff, but also can be useful with an as-built. So here we see the as-built BIM model already has the phasing in the existing phase. So you can dig right in and start a project and use their powerful phasing tools to show demo and proposed. There's no time wasted moving from the design phase to the construction documents phase of a project. Having an as-built BIM model can make it easier for you to understand a project that you haven't visited, because you can cut all those sections and view the existing spaces and roof massing in 3 dimensions. And some say Revit offers a more intuitive design experience overall and allows users to present 3D images at the planning stages to the owner or the planning departments. And so to sum up this 4th portion and the entire presentation itself, drafting from sketches into CAD is a pretty straightforward process. It takes time to become efficient, but you'll just be entering measurements into CAD straight from your sketch sheets. Modeling into Revit from sketches can be done, of course, but you may find during modeling that you'll need to ignore certain measurements in lieu of letting the powerful software just build the model properly. Drafting from a point cloud in both CAD and Revit means that you'll be importing the cloud itself into the software and essentially tracing or placing components right on top of the cloud to create your plan sets. And now we are going to open it up to all of you for questions. So I will stop my screen share. And if you have any questions, please turn your video on so I can see you, and turn off your mute, and feel free to fire away.
Hello, Colin. This is Alan.
Hello, Alan.
Hi. One question I had, I'm a surveyor. Florida code says surveying is done by a surveyor. So as-built surveys always kind of make me chuckle with architectural, but I signed on here to get deeper information on your field. So with the ZebRevo, my question with that is, are architects comfortable with the precision that has?
I find for the most part that they are. And I think on one of the slides that I showed, we usually want to get around a 1/2 inch precision. So architects that are aware of this with their as-builts are comfortable with that level of precision.
Okay.
But it's a great point that you bring up, because the data that comes from the ZebRevo is a little bit fuzzy. When you look at the wall, it's measuring it from the ground up. Sometimes you might have a bow or a bend in the wall, and it's going to have points in all of those. So it really is up to the drafter to kind of split differences and make decisions on where to place their line work within it. And it's usually the thickest part of the cloud.
Okay.
And then while doing so, using a 1/2 inch snap. A lot of architects already in their templates have some sort of snap system that they use. So we find that a lot of them are comfortable. I have had instances where a client on a larger structure, mostly commercial or industrial or something like that, will recommend using a terrestrial scanner like one of the Faros, where they have really hyper precise, but it's very painstaking and detailed process.
Right. Okay. Thank you for that. Yeah, I've wondered, if what you said was architects are comfortable with that 1/2 inch fuzz, but in your experience, how many of them know the resolutions that they're actually dealing with?
It's tough to say, I mean, I've had long conversations with some that are come up with the same question you did, and I have some that are just happy it's within a 6 inch realm, because that's something that they go out and just do kind of a 1-2 skidoo of their as-builts before that.
Okay.
And just try to have something on paper. So but yeah, that's a great question too.
Great. That's pretty much why I signed up for this webinar. So I appreciated hearing your industry insight into it. Thank you.
Yeah, absolutely, Alan. Thanks for joining. And does any of the other participants want to chime in with a question or 2 or 3? Happy to answer any questions you have.
Hi, this is Ali speaking. I just had a quick question regarding, when you said you scanned the property, how long does it take to sort of, from my understanding is, you're probably going to have to stitch the scans, or what's that process like of putting the scan together to create that point cloud? And then how, like, is it pretty easy to do it? Or what softwares are you using for that?
Yeah, great question. So most of the time you are not having to stitch anything if you're using a mobile scanner. And that's one of the points of it. It's just creating a continuous cloud. If you're using a terrestrial scanner or one that's mounted to a tripod, then you'll need to use some sort of other software and ensure that they're all linked together. They already have kind of a powerful algorithm that's starting to link them together, but you may need to check that. So with the BLK360, the software is called Cyclone, and that's what you use to put it together. With ZebRevo, it comes with its own proprietary software that you'll have to even have it function, and that with that it just processes on its own. If you do, for whatever reason, like I can come up with an example of measuring a multi-family residence where we weren't able to scan a continuous cloud and instead had to do several, you can merge them together later. And the software that I use to do that is called Cloud Compare, which is actually a free software to view point clouds. So I'm glad you asked that question, because it's kind of a crowdsourced software. It's all kept by volunteers and funded by donations. But it's also an extremely powerful and excellent tool for viewing and checking out point clouds. And it does have merge features as well. So.
Okay, sounds good. Thank you.
Thank you. All right. If no one else has any questions, I don't see any more unmutes or cameras.
Oh,
hello.
right there, Colin. Yeah, it's just questioning. I guess the new iPhone 12 has LiDAR technology. Have you experienced that?
No, I have not. I did download a program.
Oh,
I've downloaded lots of problems, but I think on my iPhone 6, I downloaded a software that you walk around the room and you touch your phone to the surfaces of the walls, and then it used some sort of algorithm to create a floor plan from it. And I mean, it was really bad, but at the same time, I was very impressed with it even coming up with something relatively close. So that's a good point that you bring up, and something to look into. But I would be hesitant to be able to gather something reliable from a phone just due to its limited capacity in that particular instance.
All right. So you don't know if the phone actually has LiDAR technology?
No, I do not. But I don't keep up with the Apple software updates as much as some others. So that would be really tricky, though, because the scanners that I mentioned in this presentation, they're shooting in every single direction constantly. So there would probably need to be some bubbled out feature even on the lens to be able to capture it like that, unless it's only a direct view and you need to really shift around as you're scanning. But you've piqued my interest with the question, and I'd love to see if that would be capable. It'd be a lot less equipment for me to bring out to in the field.
Bring your phone.
Yeah.
All right. Well, thanks.
Yeah, absolutely. Anyone else? Okay, I just want to ask one more question, and I'd love it if you could answer it in the chat. And thank you so much for attending the presentation. I really appreciate it. I hope you were able to gain some insight into this subject I'm really passionate about. So yeah, the final question that I'd like you to answer in the chat, if possible, is just what you do prior to remodel projects, and try to answer within one of these 4 parameters. And I'll just share my screen one last time here to do so, if I can. So answer this in the chat. Do you look for existing plans? Do you measure up to date validate plans using your traditional methods, or do you use scanning technology yourself? And finally, do you regularly outsource your as-builts? If you could let me know that in the chat, I would greatly appreciate it. And we'll end this session in a couple of minutes. And again, thank you so much for participating. This was my first time giving a class to the AIA, so I was admittedly nervous. I hope I didn't stumble too much. And yeah, I'm seeing some comments in the chat. That's great. If you regularly outsource and you haven't tried my company, give me a holler. Feel free to do so. But in the meantime, hopefully you learned some things in this class. Yeah. So we'll leave it open.
Actually, since you're telling us that we should hire you, I don't even know your company.
Oh, okay. Yeah, it's called
That would
Precision.
help.
Yeah.
Are you,
no.
and you're local to where? We're in the San Francisco Bay Area.
This office I'm standing in right now is in Alameda. So we are in the Bay Area, and that's my company, Precision Property Measurements. So we actually, this regional office services all of Northern California from Pebble Beach up to Crescent City, and I've been to both. So thank you for that question.
Colin, I think you should offer your email address if anybody has any questions about if they're doing their own as-builts, or if, you know, they need any help down the line.
Yeah.
You drop that in the chat.
There, that is. That's my direct email. I'm the regional director of the Bay Area branch, so I don't get out as much as I'd like to surveying, and I don't get my, I'm gonna show you something I use in drafting. Hang on. End screen share. Why won't it let me end?
I think you've got to turn off your background, maybe, Colin.
Unless you put it in front of yourself.
Or put it in front of yourself, yeah.
X keys. I don't get to use my X keys as often as I like to, but I do give all the quotes, and I do really see most of the projects through in this area. So I'd be the one to make sure you get the plans that you need. And okay, it looks like everybody's answered the poll, so I'm going to go ahead and end the presentation. But thanks again so much for coming. Thanks for listening, and I really hope that you were able to gain some insight on as-built plan creation.